use flame tests to identify group 2 ions. We want to dip a nichrome wire loop in concentrated hydrochloric acid. And we want to dip the wire loop into unknown compound. And we want to hold the loop in the clear blue part of the Bunsen burner flame and then observe the color change of the flame. So if it's a calcium ion, Ca2+, it will produce a brick red flame. If it's Sr2+ strontium, it'll have a red flame. And if it's Ba2+ barium, it will have a pale green flame. So use flame tests to identify group 2 ions. Dip nichrome wire loop in concentrated hydrochloric acid. Dip wire loop into unknown compound. Hold the loop in the clear blue part of Bunsen burner flame and observe the color change of the flame. Ca2+ brick red, Sr2+ red, and Ba2+ is pale green. And then we can also use dilute sodium hydroxide solution to identify the group 2 ions. So we want to add NaOH, dilute sodium hydroxide, dropwise to a test tube containing the metal ion in the solution. So add NaOH dropwise to a test tube containing metal ion solution, and we want to observe the precipitate that forms. So add NaOH dropwise to a test tube containing metal ion solution, observe the precipitate that forms, and we want to keep adding the NaOH in excess. So if it's the metal ions, so if it's Mg2+, slight white precipitate with OH minus, and excess OH minus, it's a white precipitate. Ca2+, slight white precipitate with OH minus, slight white precipitate with excess OH minus. Sr2+, slight white precipitate with OH minus, slight white precipitate with excess OH minus, and if it's Ba2+, no change with OH minus, no change with excess OH minus. So you can see from this table, Ba2+ has no change with OH minus and excess OH minus, and Ca2+ and Sr2+ both have the same precipitate color, slight white for OH minus, excess OH minus is only Mg2+, where if you use OH minus it's slight white, and if you use excess OH minus, it is white.